Hi everyone! In today's video I would like to show you how to add analog inputs to a Raspberry Pi. An Arduino comes with these out of the box, but the Pi does not. I have my Pi set up here and I'll be using a 40-pin ribbon cable and this breakout board to make my wiring a little cleaner, and that should make the video a little easier to follow. But you can also just connect jumper cables directly to the 40-pin header like this. I'll be using this chip to add the analog inputs, the MCP3008. You can also use the MCP3008, which has the same wiring, and I'll provide code for both in the description below. You can also use the MCP3004 and 3204, but do notice that the wiring for those is a little bit different. With this notch pointing away from me and this circle to my front left, the left side of the chip has 8 pins for the 8 analog input channels that this chip provides. And we'll use the right side for communication and power. So I'll connect the first pin on the left to 3.3 volts. I will also connect the second pin to 3.3 volts. I will connect the third pin to ground, and I will also connect the 8th pin to ground. And then we will have to use pins 4 through 7 for communication with the Raspberry Pi. This chip uses the serial peripheral interface to communicate with the Raspberry Pi. So to do this, we are going to connect the 4th pin from the front right to pin number 11 on the Raspberry Pi. We are going to connect the 5th pin on the right to pin number 9 on the Raspberry Pi. And we are going to connect the 6th pin on the right to number 10 on the Raspberry Pi. Now the final pin would usually be connected to pin 7 or 8 on the Raspberry Pi. But I like to control this pin manually myself. So I'll connect it to a random one, and let's pick pin number 12. Finally, I want to give myself a signal to measure, and for that I'll just use a potentiometer, and I'll connect the outer legs of the potentiometer to 3.3 volts and to ground, and I'll connect the middle pin to one of the analog input channels. It doesn't really matter which. So now let's go into the Raspberry Pi and check out the setup and the code. Here we are in the Raspberry Pi, and the first thing we have to do is go into Preferences, Raspberry Pi Configuration, and then under Interfaces you must ensure that SPI is enabled. Looking now at the Python code, I've essentially written the same script twice using 2 different GPIO libraries. So on the left hand side I'm using pygpio, and on the right hand side it's rpy.gpio, but other than that the scripts are identical. Taking a closer look at the script itself, we begin by just doing some setup, nothing special here. And then we take that pin number 12 and we declare it as an output. Next we have 2 functions that read from a 3008 or a 3208, and these can also be used in this case for the 3004 and in this case the 3204. And we tell it what channel we want to read from, and for the return value we get a value between 0 and 2 to the power of however many bits the device has. Here in the comments I've written out what exactly we are sending to the chip bit by bit. And then next we have a simple conversion function, so you give it the value that you got from one of these chips, how many bits such a chip outputs, and the reference voltage, the voltage that you're feeding into the chip. And then it returns the voltage that you measured at that time. The first thing we do in the main loop is pull pin number 12 low. And the idea here is that you can connect many different SPI devices to pins 9, 10 and 11 in parallel. And out of all of these devices you can select which one you want to talk to by pulling its chip select pin low. And that's what we're doing with this line here. Once we've pulled it low, we start talking to the chip using the read channel function. And so here you see that we're doing an SPI transfer inside of these functions. And once we're done talking to it, we put the chip select high again to ensure that we don't inadvertently talk to it. Once we've done that, we convert the reading to a voltage and then we print it. Here we have the completed system with the circuitry that we built, the Raspberry Pi. I've connected a multimeter up to the potentiometer so that we can cross-check whether the values we're getting are correct. And then here we have the TV that will display the output from the Raspberry Pi. Now, if you make the system like this, you will notice that the values that the Pi displays will jump around slightly. And that's because this system is quite sensitive to external disturbances and noise. So to fix that, let's add some capacitors to our circuit. I will add two ceramic capacitors of 100 nanofarads to the circuit. One between 3.3 volt and ground near the chip, and the other one between the analog input and ground. And these two capacitors together will ensure that external disturbances don't affect the reading too much. Here we can see the values given by the Raspberry Pi and the multimeter, and we can see that they're quite close to each other. And as I rotate the knob of the potentiometer, we can see that the two values basically change in lockstep and never really deviate too much from each other. So in the next video, I want to show you how you can power your Raspberry Pi from a LiPo battery like this one. And part of the danger there is that you might over-discharge one of those batteries. So I will use the circuit that we've built today to monitor the voltage of the battery to prevent over-discharging. I hope to see you then. That's all I have for you today. Have a good night.